Today we're going to be talking about using distributive property, but we're going to do it with polynomials this time. So prior knowledge, we've already covered how to do a problem when you do, for instance, 3 times 2x minus 5. So I'm just going to have one of my students out here walk me through the process. Fermat, can you work us through this problem? What would you do to simplify?
You would do you would distribute the 3 to
Okay.
the 2 and the negative 5.
And to the negative 5, so we're going to do 2 multiplications. What do you get as a result when you multiply here?
6x.
What do you get as a result when you multiply here?
Negative 15.
And can I do anything else with that?
No,
No, why not?
because there's only one variable on one side, not on the other.
Right. I can only put these together if they're alike, because remember my rules of addition and subtraction are they have to be like terms. This is to the x to the first, this doesn't even have an x, so I'm done. What's different about our new process is I'm going to start throwing other things out with this number. So maybe I have a monomial on the outside that looks like this, and maybe on the inside I have just a number, and then I have minus 8x to the third. Now we can see that even though the process is the same, the actual mechanics of multiplying these together gets a little more challenging. So if I look at just this front part here, and I say, well, I know I'm going to have to multiply twice, just like I did in my other example. I'm now going to start looking at, well, how do I multiply something with a coefficient and an exponent to something that's just a number? So, Fermat, you want to kind of chip in with what you think's going to happen? Give me a guess for what you think's going to happen.
You have to multiply 3 times 2, which gives it 6x, and then you bring the square down.
All right. Notice because this didn't have any x's on it, I just copied down the x squared. But both of them had a number component, so I combined the number components. If I move to the second part now and I do a multiplication, now both of them have a coefficient. Both of them have an exponent attached to a variable. So I'm going to have to separate that into 2 separate steps. Multiply the numbers. What do I get when I multiply these?
16.
But when I do x squared times x to the third,
You get x to the 6.
here's x squared, here's x to the third. How many do I have in total?
5.
I have 5. So what we have to be careful of is in this multiplication process, this says I have x as a factor twice. I have x as a factor 3 times.
So you add them together.
I add them together and I end up with x as a factor 5 times. So I wanted to point out the confusion. I'm multiplying the numbers in front, but I'm adding the exponents. I'm adding the degrees together to get my total degree. And that's how I'm going to multiply using distributive property when I have variables mixed in.